All right, it looks like we can begin, Michelle. All right, I think we are now recording, and I will go ahead and start. I'm Marta Fuoco. Good afternoon, everyone. I am in the Air and Radiation Division in the Air Monitoring section. I've been in the Air Monitoring section for 17 years now, and I work on data analysis. I do some sensor work. I work on mobile monitoring, and also do some community work as well. And I'll be talking the first half of this presentation or this training, and Rachel will be talking as well.
Yeah, so I'll just quickly introduce myself as well up front. I'm Rachel Kirpus. I also work in the Air and Radiation Division here in Region 5. I'm in the State and Tribal Planning section. So I work on a lot of our grant programs. Some of you may have me as your project officer for these grants moving forward. I've been with EPA just over 2 years, but before that, my academic training was as an analytical atmospheric chemist, so happy to help out today on our air sensor webinar.
Great, let's get started. I'm going to start by talking a little bit about air quality and monitoring tools that we have and the basics of regulatory monitoring. So air quality is a term that is used to describe how much pollution is in the air. And we care about air quality because air pollution can affect our health. We know from scientific literature that links air pollution to health problems, including decreased lung function, the aggravation of respiratory and cardiovascular diseases, increased asthma prevalence, incidence and severity, and premature mortality. It also can affect our environment, resulting in reduced visibility and damage to plants and animals. Air pollution is a result of both man-made and naturally occurring sources, and these pollutants can be short-lived from a couple of hours to a couple of days. It can also persist in the environment for years. So Rachel, if we can just move on to the next slide, please. Thank you. So we have many tools at our disposal to measure the levels and different types of pollution that we find in the air. But even with what we have, it's important to remember that we're limited with the types of pollutants that we can measure. So when we have a specific question or a measurement need, it's important to match that with a device that measures the pollutant of interest and provides sufficient accuracy, reliability, and traceability. And so these tools that you see vary in cost and spatial resolution. And so they include, starting at the top left, fixed locations, such as these reference monitors that you see, that are used to determine compliance with the National Ambient Air Quality Standards, or NAAQS, and you're going to hear a little bit more about that soon. And these monitors must meet strict operating and performance requirements that are outlined in the Code of Federal Regulations. And again, I'll talk about this a little bit more in a minute. And these reference monitors produce very high quality, accurate data, but they require precise operation, siting, and quality assurance practices. So another tool that we have that you see here in the middle are these research instruments, which can range from lower cost sensor technology to mid-range prototypes, all the way to high-end laboratory grade instruments that are modified for field use. Here on the top right, you'll see mobile vehicles, such as the one that we have here in Region 5. Those are part of our remote sensing tools, which are used for measuring pollutants over large spatial areas. And then finally, on the bottom, you'll see air sensors, a class of technology that are lower in cost, more portable, and easier to operate than reference or research instruments. Today, we're going to focus on two of these tools, and you'll hear more about the basics of regulatory monitoring from me. And then you'll see how these core concepts of regulatory monitoring can be applied successfully to sensor deployment from Rachel. We can move on. Thank you. So the Clean Air Act calls for states and EPA to solve multiple air pollution problems through programs that are based on the latest science and technology information that we have available. The Clean Air Act authorizes EPA to establish National Ambient Air Quality Standards, or NAAQS, to protect public health and public welfare and to regulate the emissions of hazardous air pollutants. The Clean Air Act also allows individual states or tribes to have stronger air pollution laws, but they cannot have weaker pollution laws that are set by EPA. 40 CFR Part 50 of the Clean Air Act requires EPA to set national ambient air quality standards for 6 principal pollutants, which can be harmful to public health and the environment. And these, as most are aware, are CO, lead, NO2, ozone, PM 2.5 and 10, and SO2. The 40 CFR Part 50 also identifies 2 types of national ambient air quality standards. And these are the primary standards, which provide public health protection, including the health of sensitive populations, and secondary standards, which provide public welfare protection, which include protection against decreased visibility and damage. And so the NAAQS are defined by 4 parts. You'll see that they're defined by an indicator, so the pollutant that we're interested in, the averaging period. So for example, 1 hour, 8 hour, 24 hour, or annual. And then there's a statistical form for each of these pollutants. So for example, the 3-year average of the 4th highest daily maximum 8-hour concentration. And then finally, there's the level, the concentration that is set. So how do we know how we're doing? Within the United States, Puerto Rico, and the US Virgin Islands, ambient or outdoor concentrations of criteria air pollutants are measured at more than 4,000 monitoring stations that are owned and operated by tribal, state, local, and environmental agencies. Each of these sites measures 1 or more of these criteria pollutants that I just mentioned using approved instrumentation. In managing these instruments, the agencies are required to follow stringent siting criteria, extensive operational plans, and quality assurance procedures, such as calibration, maintenance, audits, and data validation procedures to make sure that they're producing high quality data. If you want to read up more about that, you can visit EPA's QA handbook that further describes these procedures. Section 319 of the Clean Air Act requires an ambient air quality monitoring system throughout the US to meet multiple objectives, and also indicates record keeping with respect to this data. It also supports periodic analysis and reporting to the public. And so these objectives that are outlined include protection of human health and welfare, supporting compliance with the NAAQS, providing timely and real-time air quality data to the public, validating emission models and verifying control strategies, and also supporting air pollution research studies. And when we're looking at siting, the monitoring sites must be capable of informing about many things, including looking at peak air pollution levels in an area, looking at typical levels in populated areas, looking at how air pollution is transported into and out of a particular city or region, and also looking at air pollution levels that are near particular sources. So how do we access this data? Agencies send this quality data to EPA's database called the Air Quality System, or AQS for short. Then Air Data, which is a website, airdata.gov, retrieves the air quality data from AQS and provides the public with data visualization and summaries. And in the next slide, you'll be able to see an example of what AirData.gov provides. And so here you'll see when you go to airdata.gov, you'll be able to download raw data. You'll be able to take a look at where monitors are located across the US. You'll be able to sign up for an RSS feed to keep up with pertinent information. You'll also be able to create using drop-down, easy to use drop-down menu summary reports that you are interested in. There'll be data visualization tools, and there's an example on the bottom right of one of the tools. And again, it's a user-friendly drop-down menu where you select your area, you select your area, your pollutant of concern and what you're interested in, and it creates these data visualizations for you. And also you can download technical reports. So as you heard earlier, air pollution can have a number of serious health effects. And for all criteria pollutants, except for lead, EPA has established the Air Quality Index, also called AQI. So the AQI was established as a method to translate pollution measurements into potential health effects. It's a numeric scale for reporting air quality that describes how clean or how polluted the air is in a particular location, and any associated health effects that may result from exposure to that air. So if you look at the table on the bottom left, you'll see that the AQI scale runs from 0 to 500, with higher AQI values indicating greater levels of air pollution and associated health concerns. So for example, an AQI value of 50 or below represents good air quality, while an AQI value over 300 represents hazardous air quality. The AQI is also divided further into 6 color-coded categories, as you see in the top and bottom left tables. And each category corresponds to a different level of health concern. This color coding allows the public to quickly identify whether air quality is reaching unhealthy levels in their communities. And so the AQI is calculated based on data that is averaged for 1, 8, or 24 hours, depending on the pollutant, because pollutants affect the body in different ways. And the specific concentration breakpoints for each of these 6 levels vary by the individual pollutant. But for each of these pollutants, the AQI value of 100 generally corresponds to an ambient air concentration that is equal to the level of the short-term NAC for that pollutant. At AQI values that are below 100 are generally considered to be satisfactory. AQI values that are above 100 are considered to be unhealthy for sensitive groups. And then as that AQI increases, it's unhealthy for everyone. So you may have seen the AQI mentioned in the media or the local paper, or maybe you've even heard, on the news or on the radio that, oh, today is an orange day, or today's a green day, or today's a red day, with an associated health message. This is where they're getting the media is getting their information from, is from Air Now. So you can also look up your local air quality by going to airnow.gov and entering your zip code, or there's an app that you can download and your phone's GPS will direct you to your local information. So in closing for me, we've heard a little bit about the requirements for running a reference network and what it entails. We'll go over now at the end what other differences there are between regulatory and low-cost sensors before Rachel takes over and focuses more on sensors. And so when comparing reference and low-cost sensors, there are a number of differences, a number of important differences. Typically, the cost of a reference monitor is much more expensive than a low-cost sensor. Reference monitors can cost up to $50,000, where a low-cost sensor is somewhere between $100 and $2,500. To operate the reference monitor is very expensive and resource intensive. It is relatively inexpensive to operate a sensor. When looking at siting a reference monitor needs a fixed location. It needs to be brought indoors from the elements, so that requires a building or a trailer. Generally, low-cost sensors are portable, and they're also made so that they can withstand the elements in most cases. To operate a reference monitor, you need highly trained technical staff, and in most cases, when you order a sensor, they're pretty plug and play as soon as you pull them out of the box. We know that for reference monitors, the data quality is known and consistent and high quality and under various kinds of conditions. For low-cost sensors, this may not always be the case. The data may be of unknown quality and may vary not only from sensor to sensor, but also may be impacted by weather conditions. The operating lifetime of a reference monitor is more than 10 years, providing that all the necessary maintenance is done to the site. Sensors are known to have a short lifespan, about a year or so, and they may become less sensitive over time. Also, the maybe most important thing to remember is that reference monitors are used for regulatory monitoring and low-cost sensors are not. So I'm gonna, with this, we're gonna move on to Rachel, and she's gonna start talking more about sensors.
Great. Thank you, Marta, for all of that great information and background on NACS, AQI, and regulatory monitoring. So I'm going to transition now into speaking more about air sensors, what they are and what they can be used for. But to start off, just want to make sure we're all on the same page because, sometimes different terms are used and the term air sensor can kind of cover a broad umbrella. So we define an air sensor as a class of non-regulatory technology that's typically lower in cost, can be portable, and generally easy to operate than regulatory air monitors. Air sensor often describes an integrated set of hardware and software, typically uses one or more sensing elements to detect or measure pollutant concentrations, and typically instantly or relatively quickly. And air sensors may also be called low-cost air sensor devices, air sensor pods, or air quality sensors. But in general, we're referring to an air sensor as, any of these technologies that are not regulatory monitors. And to reiterate what Marta has mentioned, sensor data does not meet any of the previously described requirements for regulatory monitoring. And there are no studies to support ozone or PM 2.5 health effects messaging using sensor data. So sensor data is not equivalent to AQI or NACS. So we just want to, make sure everyone understands, temper your expectations, as the slide says, on what sensor data can be used for. We will discuss there are many great applications of sensor data, but it is, again, not equivalent to the regulatory monitoring that EPA uses to define our AQI or NACS standards. And I have a short video here that just goes over a nice summary, again, the comparison of regulatory data and sensor data quality.
Understanding the kinds of outdoor air quality data that are available and how that data differs can help you determine how they may be used. Let's start with the data collected for regulatory purposes. The Clean Air Act directs EPA to limit levels of air pollution in the outdoor air. The agency sets national ambient air quality standards, called the NAAQS, for pollutants that are common in outdoor air, considered harmful to public health and the environment, and that come from numerous and diverse sources. These pollutants include carbon monoxide, ozone, lead, nitrogen oxides, particulate matter, and sulfur dioxide. EPA, states, and tribes place air quality monitors in high population and high pollution areas across the United States to evaluate air quality. These instruments must meet strict EPA or state environmental regulations, both initially and over time. Because our regulatory decisions affect human health and may impose costs to improve air quality, EPA requires rigorous quality assurance and quality control procedures for this monitoring network. These include requirements for where monitors are sited, as well as how samples are collected and analyzed. Regulatory monitors are operated and maintained by trained staff. EPA is confident that the air quality measurements this network provides are accurate. In comparison, air quality sensors can be portable, less expensive, designed to be low maintenance, and require minimal training to operate. So how can we put sensors and their data in context? It depends on your objectives and purpose for measurement. Air quality sensors and crowdsourcing allow for more measurements over space and time. Sensors, for example, may be helpful in hotspot identification, monitor siting, and exposure pattern identification. They can also help inspire behavioral changes and educate people about pollution where they live, work, and play. However, sensor performance can be highly variable. They may provide less accurate measurements than regulatory monitors and may not operate well in extreme environments, like high temperatures, humidity, or pollution. Also, many people operate sensors with limited, if any, quality assurance. Currently, some sensors lose their ability to take accurate measurements over time. Finally, sensors may provide data outputs every minute or second. Note, with more frequent sampling, there can be greater uncertainty in the measurement itself and how to interpret any potential effect on your health. If you're looking at sensor data, you need to ask yourself some questions about what you're seeing and how to make sense of that data. Where can I go to learn about the performance of different sensor units or manufacturers? How will I use the information to inform decisions about outdoor activities? How should I interpret the raw or processed sensor measurements? Are the measurements collected every second, minute, 15 minutes, or hourly? How does this information compare to what EPA shows on air now? These questions are important to consider when deciding how and when to use regulatory versus sensor data. Learn more at epa.gov/air-sensor-toolbox.
All right, so that video again gave a nice just refresher of some of the information we've heard so far from Marta, and is also a nice plug for our air sensor toolbox, which you'll see referenced and linked throughout the rest of this presentation, as a lot of the information we will go over now is included in that toolbox, and we can also provide the link to the toolbox as well. So as the video, briefly mentioned, there are several great applications for air sensors, including for just general education or information and awareness about air quality. Can be used for source identification and characterization or hotspot identification. Air sensors may be used to supplement existing air quality monitoring networks or exploratory monitoring. They may be used for personal exposure monitoring, and air sensors may also be used in research. So as you are designing a project and considering using air sensors to collect measurements on air quality, there's these 6 key questions to consider that are highlighted in the air sensor toolbox, and in the there's an air sensor guidebook included in the toolbox, which I know Marta just let me know that we have a new revised version of the air sensor guidebook available now as well. So we can share that with y'all after this meeting as well. So first, you should determine what your goals are for the project, which of those uses of air sensors best describes your project or what you want to find out. And then think about what measurements are needed to meet those goals. So determine what specific pollutants that you want to measure, as well as any additional information that you may need or data to collect, including meteorological information like wind direction, temperature, humidity. If you're going to do any sort of portable monitoring and you want to have GPS location data associated with that, etc. And then you can consider what design features you need in an air sensor, including, do you need something that is portable? Think about what the power source is. Does it need to be plugged in, or does it run on battery power? Are you interested in indoor or outdoor monitoring? And what sort of data storage considerations do you need? And also consider the factors that might influence the cost of purchasing a specific air sensor, and then also costs to operate and maintain. Just think about the general maintenance that may be needed, considerations for how data will be transmitted from if data goes from the sensor to an application on your phone, or if you need to download data, etc., and how data might be visualized. Consider, again, the accuracy of the air sensor. Are there independent evaluations that have been done? We'll discuss this a bit further in a few slides. Yeah. And try to find evaluations that have been done in similar conditions to what you're interested in measuring, and think about what data quality checks that you will need to do throughout your project to ensure that you are collecting accurate data. And then also think about, what other supporting information is available, what might be included in the user manual. You'll want to know what the capabilities of the sensor are, what measurements are collected, instructions to install and operate, etc. And just a few more questions to consider as you're, starting out designing a project. Starting from what that overall goal is, think in a little more detail what you want to find out specifically, or what information you would want to be able to show with those measurements. Is the, air quality issue you're interested in a nuisance, or is it a health hazard? Is it something that is a recurring problem? Do you know the normal levels of your pollutant of interest, and if there are any seasonal or day-night profiles? Understanding what the normal concentrations and trends of a pollutant are will then allow you to design your project and monitor in a way where you would be able to detect any high concentrations, etc. And then again, think about what supplementary data you should collect so you can answer your questions. And as you're thinking about what sensors best suit your needs, and then also as you for these grants, which are you're all preparing for, which is why you're on your webinar today. When you go to write your quality assurance project plans, as Melanie discussed last week, you will have to consider data quality objectives. So these might include the accuracy, which would be the overall agreement of a sensor's measurement to the true value. So in this target illustration, the arrow like hitting right on the bullseye would indicate that's an accurate measurement. Also consider the precision, which would be how well sensor measurements are reproduced under identical circumstances. So in the illustration here, we see the 4 arrows all hitting different places on the target. So this may not be very precise, even though if you averaged those out, you might end up with a fairly accurate value. So precision and accuracy are both very important to consider, as well as the bias, which would be a measurement error. So in this third target illustration, you see multiple arrows all close to each other on the target. So in this instance, you may be getting precise measurements, but ones that aren't the most accurate because we are not hitting the true value. And a lot of times there might be a kind of if there's a consistent bias, if a sensor consistently measures a higher concentration or a lower concentration than the true value, or when comparing to, for example, a regulatory monitor, those are things that can then be calibrated for or corrected for, but you just need to be aware of how the sensor is performing in order to interpret the data correctly. And finally, another data quality objective to consider would be the sensitivity, which would be the lowest detection limit of the sensor. So in this final illustration, we're representing a kind of a larger, fatter arrow would mean this is not as sensitive. You might not be able to measure very, very low concentrations of a pollutant of interest if the sensor chosen is not extremely sensitive. So in the air sensor guidebook that previously mentioned, there is a great resource in here that provides suggested data quality objectives depending on what the goal of your project is. So again, that's why it's important to first determine what your overall goal is, because if you're just interested in like education or general information, then you may not need measurements that are as accurate or precise as if you are interested in supplementing monitoring done, through a regulatory network, or doing a hotspot identification or something, etc. And in order to evaluate how different sensors perform in these data quality objectives, there are resources available where existing evaluations have been done. So in the air sensor toolbox, there are resources available for evaluations of a whole slew of air sensors measuring different pollutants that have then been co-located with a regulatory monitor for some period of time to compare and then evaluate their performance. And then there's also similar studies available from other resources, such as the South Coast AQMD is one that's great. And in the next slide, I'll zoom in a bit on what this table is showing here. So I just want to point out this is a great resource. There might already be a lot of information available for the particular sensors you may be interested in. I will mention that for this resource and for all of EPA's resources, any mentions of specific brands of sensors or products, again, do not equate an endorsement from the EPA, but this is just a tool to try to provide information that may be helpful to you as you are looking for the right tool for your project. So in that evaluation resource, there's a lot of different information included, starting with the detection approach. So this explains how a particular sensor measures the pollutant of interest. So in our regulatory monitors, as Marta discussed, are the gold standard federal reference monitor for particulate matter, for example, actually collects particulate matter on a filter, and then that's weighed with like a really precise scale, and the concentrations are determined via mass. Whereas our federal equivalent methods, that are popular, deployed in regulatory networks for PM, use a light scattering method to then determine the concentration of the particulates. So most low-cost air sensors used to measure PM also use a light scattering approach. But there's a few different methods that may not be as, again, accurate or precise as the technology that's used in our regulatory monitoring. The evaluation resource will also provide details on the operation of each sensor and information on how the test for the comparison with the regulatory monitor was conducted. So whether this was in the field or in the laboratory, under what sorts of conditions the measurements were taken in the field, what time of year, what sort of temperatures it was tested under, et cetera, and then what reference monitor was used for the comparison. Also provide data on the how long the test was conducted, and then how the data was averaged. As we mentioned, a lot of the sensors can collect data at a very high frequency, either every minute or every second maybe, but that data will typically be averaged out maybe to an hourly concentration to compare with the regulatory data. And then maybe most importantly, for considering these evaluations and determining the best sensors for your use, they'll report in R-squared value, which is a statistical term that represents how well the sensor performed in comparison to the reference monitor. And that would be from 0 to 1, 1 being the best comparison. So use the information available from the manufacturer, as well as from these independent evaluations available from our toolbox and other sources to evaluate sensors that you might choose for your project. Again, consider what conditions those comparisons and evaluations were conducted under to make sure it's similar to your intended use. And seek, information on the appropriate data quality checks that should be used for each sensor. And just, a few more questions to consider as you're to select your monitors here. Again, think about what pollutants you want to measure, what sensors might be available for those measurements, the location you want to take measurements in, whether you need a sensor that's portable or handheld or something that will be stationary, how long you want to take measurements, and if you're interested in, a certain season, if you're interested in trends over time or day versus night, etc. Then how will you ensure that quality measurements are collected? So how will the sensors be calibrated? Is there information on how to calibrate the sensor available from the manufacturer or other sources? How will those data quality objectives we mentioned, like precision, bias, etc., be estimated? And then if there isn't any evaluations for your sensor of interest available, will you do your own evaluation, maybe by trying to co-locate that sensor with a regulatory monitor or some other way to validate how the sensor is performing? Do you have standard operating procedures written so you know that measurements will be taken in a consistent way? This will be very important, particularly if you're designing a project where there'll be multiple people who might all be responsible for collecting measurements with different sensors. You want to make sure that all of the measurements are done consistently. And we have resources available from our office and in the toolbox to help with these standard operating procedures as well. And then consider what sort of training you might need to operate and maintain the sensors, or what training, if you're coordinating a project where there might be volunteers who will be going on collecting this data, what sort of training might be needed to ensure that quality measurements are made with the sensors of interest. Once you've design your project, determine what sensor is best for your needs. There's some important things to consider when you go to site and install the sensor. So again, consider, based on the goals of the project, what location should the sensors be placed in. If you're interested in, trying to detect pollutant from a certain source, making sure that the sensor is installed in a location where you would be able to detect that pollutant, but also, making sure that you're not going to be, if there's not going to be any other nearby sources that might interfere. Consider the security, right? If you're going to be installing sensors in, a public place or an area where people might have access, make sure that everything can be done safely. But then also consider, making sure that the people who will need to have access to the sensor do. So if you're going to have a sensor installed maybe at someone's home, making sure that if anyone needs to come in and do any maintenance or there's some, general guidelines for the placement of the sensors. Generally, we want to have it placed at least 6 feet above ground level on a rooftop, or, somewhere where it will be away from any obstructions, or including, vegetation, trees, etc., or any other emission sources. Determine what the power requirements are. If the sensor, needs to be plugged in, making sure there's access to that. If it's battery powered, making sure that you'll have access to the sensor to replace batteries as needed. And then it's always good to take photos to document the location and how the sensor was installed, just so, if you have that all documented, and if there's any questions later, you can go back and say, oh, like, looking at these photos, we see that there is maybe a potential source that we weren't aware of before, etc. Make sure that you have the any communications access that you need for the sensor. If the sensor relies on Bluetooth or Wi-Fi, make sure that you have a strong connection where it will be located. And then again, just document information about the site, where it is, any, potential nearby emission sources or obstacles, when it was installed, etc. There will be additional considerations to site and install the sensor if you are interested in measurements outdoors versus indoors. So we've discussed a lot of the outdoor considerations already. Make sure you're avoiding any potential pollution sources. You don't want to install your sensor, out on a back patio where someone's going to be, out there grilling every day. If you're trying to measure PM concentrations, for example. If you're installing the sensor inside, then, think about what activities are conducted in those spaces, if there's going to be, any nearby sources, if you're going to be getting, picking up measurements from activities like cooking, or if someone is smoking. For example, think about how many people occupy the indoor space and at what times of day. If there's windows and doors that may often be open, are there any air cleaners or air purifiers that are operating the space? Do you know anything about the HVAC operation and maintenance, etc.? And again, this information in more detail is available in our air sensor toolbox. So after you've installed the sensor and you are collecting measurements, it's a good idea to do some data analysis along the way, not just, at the end of your measurement periods, just again, to do some data quality checks and make sure that you are collecting the measurements you're interested in and there's no other sorts of interferences. So the first analysis check to do would be to just create a time series of the data, concentration versus time, and just the raw data as it's reported from the sensor. And then look to see, are you seeing any spikes? Any really just like short-term like spikes in high concentration? Because this could be indicative of a hyper-local source, like, oh, you might see a spike if someone was smoking right near the sensor, or you might see a spike indoors when someone was cooking. If you see spikes that seem routine, this could be, indicate the sensor is picking up something like an air conditioner going on and off. So again, that's why it's important to, think about, do you know, like, what activities are happening in this space? Do you know information about the HVAC, et cetera, if it's going to be inside? If there's random spikes, then, that might indicate there's, fluctuations in the power supply or something. Then if you take that raw data and then maybe average it out, so you're looking at hourly or daily concentrations, and then you compare that to, the nearest regulatory monitor, or compare it to other sensors that are nearby, then kind of just as like a gut check, look to see, do the long-term trends agree? Are you seeing, concentrations increase as the nearby sensor also sees concentrations increase, and vice versa? If the long-term trends agree, but then you see, then you're seeing an increase in the sensor this time or that, then that's likely a local source. And again, this is just kind of the gut check, a great use for the air sensors is to be able to collect measurements at a more detailed geographical scale than our regulatory monitors. So just because things don't exactly agree all of the time doesn't mean that the data is not accurate, but just be aware of what the trends are and what the differences are in your data so you're able to interpret that. And then if you do see anything that, if you see anything that is indicative of a nearby source that you aren't intending to measure, for example, then consider, relocating your sensor. So this is why, again, it's important to do some data analysis along the way so you can, make revisions or move the sensor as you need, so you ensure that you're getting the measurements that you want to. And then again, other things, even, traffic patterns might change or a tree might grow. So something that wasn't an issue when you started the project, if you're interested in taking long-term measurements, then, as you go on, you might need to make adjustments. And just a few more questions to consider for your overall data analysis and any presentation. Think about how your data will be analyzed, what other measurements might you be comparing to, how will you differentiate the source you're trying to measure from any background concentrations. And are you going to average your measurements? And if so, how do you want to look at hourly measurements, daily measurements, etc.? And then how will you present this data? How will it be displayed? Who is your target audience for this data? Are you going to try to report this data to someone? If so, how do you have plans to follow up? If you're trying to detect measurements from a specific source, do you know the people who are creating those emissions? Have you in the past, etc.? So how are you going to use the data you've collected moving forward? And just to kind of wrap up here, discuss just a few of the challenges in using air sensors to be aware of, starting with challenges that we've identified from EPA. This slide, Marta has kind of collected what people in our organization have identified as some challenges as we see air sensors being used more and more. Beginning with the resources, though air sensors are less resource intense than regulatory monitoring, it still can be difficult to gain expertise without dedicating significant time and resources. And then from our perspective, someone might see a high concentration on a sensor and then want a response from a regulatory agency right away, and that's not feasible. Again, for a lot of the reasons that Marta mentioned, as how we use the regulatory data to determine the NACs and the AQI, etc. And this leads into the second challenge in the framing, just to remember that we can't directly compare sensor data to our regulatory data or to the AQI, and the air sensor data likely is not always as accurate as our regulatory monitor data. And considering education, a lot of these air sensors are really cheap, really accessible, which is great, but and have to be aware that whoever is using the data, if they haven't been properly trained or don't know how to interpret the data, then you might not be getting accurate results. And there, for considering performance targets, again, there isn't really a great standard for comparison, between different sensors, which can make it difficult to communicate results, and even to know then what data is accurate or not. And there's also challenges in the data transparency sometimes, as a lot of these, the sensor manufacturers might be using algorithms to analyze and report that data out that they might not, they might consider proprietary and are not made available. So it sometimes it's difficult to understand how these sensors are calibrated, or how we can again compare that data to data from other products. And then just some other challenges to consider more from the user end. The sensors might not always be sensitive enough for the pollutant of interest. As was mentioned earlier, lower high temperatures, high humidity, etc., might cause inaccurate readings. And the sensors just might require field calibration and maybe more often calibrations to provide accurate data. Not all air sensors are weatherproof. So if you want to install sensors outdoors, some of them might require some sort of physical enclosure around them. some, air sensors may become less sensitive over time, particularly sensors designed to measure different gaseous pollutants. So they might have, just a limited lifetime. Some sensors don't display the data like on a screen in real time. You might be relying on a connection, to an app on your phone to be able to see the data. And then as you mentioned a bit earlier, there might be specific data communication methods, like, you might need a Wi-Fi connection or a Bluetooth, or you might need a cellular connection in order to download the data. And like all technology, sensors, might not collect data 100% of the time. And, technology can malfunction, the power supply can go out, weather might interfere with the readings, etc. So, just keep that in mind for what your project goals are, and maybe and for how long maybe you need to design a project to collect measurements for longer to account for any time the sensor might be offline. But we hope by attending this webinar today, and then by also having access to some of the resources we discussed today, some of the others on this slide, that will be able to mitigate some of those challenges and be able to use air sensors to collect accurate data for to help answer the questions that you have in your projects. So we just have the new Enhanced Air Sensor Guidebook, which is a really, really good resource available from EPA's Air Sensor Toolbox. I highly recommend that you take a look through the guidebook before you start writing your quality assurance project plans, because this will provide a lot of information that will, that covers a lot of the questions you will need to answer in that CLAP. We mentioned the reference evaluation tools that have been provided in the toolbox. And then there's also this macro analysis tool you can use if you're going to do your own evaluation, that just makes it really easy to, plug in data and plot correlations between a sensor and a co-located reference monitor. We mentioned some resources available from the South Coast Air Quality Monitoring District. It's another organization that has a lot of resources out there. There's another resource available from the toolbox. This Retigo is another tool to make data visualization really easy. So again, you can just plug your raw data from the sensor in, and you can plot time series, or you can plot concentrations, over a spatial area, etc., really easily. So again, just one-stop shop for all your air sensor needs, our air sensor toolbox. But again, or your project officer, once they are assigned, myself, Marta, are also great resources when you have questions. From EPA's Office of Research and Development, there's additional resources available. There's a report on air sensor performance. There's other resources for designing sampling plans and doing quality assurance. And then in our office in Region 5, we have additional resources available as well, including a air sensor loan program, some other resources for CLOPS and SOPs, and other guidance for groups that may be using sensor data. So with all of that, I'm sure some of you may have questions, or you may just be digesting all of this information. But I'll leave this little, again, the last plug for the toolbox up here, and we can open it up to questions you might have. And if you have any questions, feel free to write them in the chat. You can raise your hand, or you can just go ahead and, come off mute.
Hi, my name is Lori Locklear, and I have a question regarding the monitors. Do you provide a list of monitors that we can purchase or rent or lease, and what each monitor does and how precise it is?
Rachel, do you want me to try to answer that? Lori, are you
Yes.
asking about the sensor loan program that we have in the region?
Yeah, so do you provide the monitors for us, or do we have to go out and seek them from somewhere else?
So the region has a loan program where we have a limited number of sensors that are available to rent for short durations. We do a
Okay.
lot of loaning out to community groups, to libraries, to schools, but these are for shorter durations. And these are mainly PM PM sensors that we have that we loan out as part of this loan program.
So when you say PM, do they handle hotspots and supplemental, or is that what those are designed to do?
So sensors can be used to identify hotspots, and some community groups have used sensors to walk around communities and identify areas where the concentrations are increased relative to the concentrations that they've been collecting. If you would like a list of the sensors that we have in the loan program, we can share that with you. And actually, if there's any kind of, as this training as the recording concludes and that recording is shared, we can include information about the loan program when this recording is or the link to the recording is sent out.
So do your sensors are the kind that you walk around a handheld where you walk around, or are they stationary?
So it depends.
Okay.
There we have a number of different manufacturers, sensor manufacturers that we have in-house that we have purchased. Some of those are best used stationary, where you attach it to a light pole or to a mailbox, and then look at that data online. There are some sensors that are made that you can clip on your backpack or on your purse or on your person and walk around. So
Okay.
we have various kinds.
Okay. Thank you.
Sure.
Oh, I have one more. So will you be able to provide us with a list of other sources if your sensors don't meet our needs?
So we generally direct anyone that is interested to the resources that we have on the toolbox, and we can give you a direct link.
Okay.
Where they have taken sensors that are on the market and they have evaluated them. And so that's a really nice resource, because you can look up by a pollutant that you're interested in, and then it lists all the sensors that they have tested. And then you can decide for yourself, based on those sensors that have been tested, which sensor is most applicable to the questions that you have, or the questions that you would like answered. And then, of course, if you have any questions during this process, you can reach out to us.
Great, thank you.
Yeah, that evaluation list is really comprehensive, which is why, I showed a little screenshot in the presentation that was probably really hard to read, because it's like part of just a giant table with lots of sensors for several different pollutants where those evaluations have been done.
Yeah, we're going to have people help us decide those factors, more like scientist type folks that can help us determine what's best for what we want to do. So thank you.
Sure. Any other questions?
Oh, I see a hand raised somewhere.
Yeah, that's me.
Daniel, go ahead.
Yeah, hi. I guess my question is, So I guess what I'm hearing is that for at least for our project, we are working across different regions, and we should probably, and we propose a budget obviously to buy sensors. Should we buy the same type of sensor for everyone, for all our community partners, in order to provide you with a, with this kind of the same quality data, or how should we proceed? Or should we think about the specifics of where these communities are located at and plan for different sensors? I guess.
So again, I mean, is starting off with what the goal of your project is. If you're, interested in measuring the same things in different communities, then, it would probably make sense to have the same sensor. So you'd be able to compare that data. And then again, just for like ease of kind of training and understanding how to operate the sensor, and analyze the data, having the same type of sensor in different places would probably make that easier. But if you're, if you're interested in measuring multiple pollutants, then, oftentimes it makes sense to, purchase a sensor that is, sensitive to a specific pollutant. So if you want to be looking at PM and you want to be looking at ozone, that might require two different sensors so you can get like really good quality data for both of those pollutants. But yeah, Marta, I don't know if you have anything to add.
You answer that.
Okay, thank you.